Today we're going to talk about properties of parallelograms. All right. Anybody know what a parallelogram is? Raise your hand. So we're going to define it for you before we start, of course. Tony, what do you think, sir?
Parallelogram is a quadrilateral with,
Good.
with the opposite angles congruent.
Actually, we don't define it that way, but that is true. We define it a little bit differently than that. But that is true statement, but that's not the definition. Yeah, John? Two pairs of parallel sides. Or yeah, okay. Yeah. Close enough. Here's the picture. Here's the definition. So they say, by the way, what do you think this symbol means? Yeah, so we could use that symbol, okay? So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. And Tony, hold on to that thought, because actually that's one of the theorems we're going to study today. So just the way we define a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Okay? So write this down. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Okay, as you can see on the picture, you see how they have these arrows, right? One's opposite sides, they have parallel sides. Okay, does anybody know anything about then opposite side of these parallelogram? Anybody know anything about the opposite sides of parallelogram? Not only that they are parallel, there's another thing that you could say about the opposite sides. Andrew? They are congruent is correct, and guess what? That's the theorem. Okay. So here's our next theorem. First theorem of this section. Opposite sides of a opposite sides of a parallelograms are congruent is our theorem. Okay. So write that down. Right, draw the picture, and guess what those red dotted line is going to be? That's going to be the auxiliary line that helps us to prove the theorem. Okay, and then notice notice the angles that they give you. They name these angles, right? So those are going to be helpful for us to prove. Okay, so every time you see these red things on the theorem, those are sort of a hint. Okay? So we're gonna talk about how to prove this, but write this down first. Okay, yeah, go ahead. Oh, pictures? No, it's okay. So how would you go about proving this theorem? Again, a lot of you noticed that the auxiliary line EG is going to be helpful for us. Yes, Josh, what do you think, sir?
Since H, E, and GF are parallel,
sure.
then
How do you know, by the way? Very good point. How do you know that H, G, and EF are parallel?
because a parallelogram is
Right, so what would you write as your reason? Exactly. You're going to have to use the definition of parallelogram to say that HG is parallel to EF. Yes, keep going.
And then so since the auxiliary line
Mm-hmm.
goes through it, the alternate interior angles are congruent.
Good. Which are the alternate interior angles if I'm talking about HG parallel to EF? Kevin?
3 and 4.
3 and 4. How many people agree with Kevin? Good. What about 1 and 2? Are they alternate interior angles of the two parallel lines HG and EF caught by a transverse to EG? No. But what do you know about angle 1 and 2? They're also congruent. Why? Who could explain why they are? How about, okay, Jason?
HE is equal to G.
Yes, HE is, yeah, that's what we want to show, that HE is congruent to GF. But then, yes, HE is parallel to GF. Why? Because, again, class by the definition of parallel lines. I mean, parallel lines. Definition of parallelogram. Does that make sense? Okay, so we have to state that, right? Even though it may be really obvious to us that we have a parallelogram, of course, the opposite sides are parallel. But if you want to use the theorem that says if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. If you want to use that, guess what? You have to state this fact that HG and EF are parallel. Also, HE and GF are parallel because of the definition of parallelogram, right, Nicole? So then, how's that helpful? That angle 1 and 2 are congruent and 4 and 3 are congruent.
Because then you can prove that triangle HG is congruent to triangle
Good. I like how you said HEG and then FGE. You're right. Those are the corresponding, right? Look at this angle right here. HEG is corresponding angle to which one? Angle E, angle 1, EGF. Very good. Okay. Yeah. By what? Why are the
Because angle, side angle.
angle, side angle? And have we said the side part? We only said angle.
Oh.
So what do you have to say before you say that? Good. EG congruent to EG itself. Very good. So if you're going to use angle, side angle, you have to show all those three parts, right? Does that make sense? And of course, if those two triangles are congruent, you're done because HE and GF are the corresponding parts of congruent triangle. So is HG and HG and EF. Okay? HG and we should say FE by corresponding parts, right? Question?
You have to write draw EG.
Right. Because why? What would your reason be?
Within any 2 points is 1 line.
Yeah, through any 2 points, there's exactly one line. Okay, so here is the sort of a summary. Who would like to read us this summary? Let's see whether we agree with what they say. Yes, how about Andrew? Go ahead, read.
Draw segment EG to form triangles with corresponding sides EF. Segment EF and HG, FG, and EH.
Mm-hmm.
Use the pair of alternate interior angles, angle 1 and angle 2, angle 3 and angle 4, to prove the triangles congruent by A.
Isn't this what we said? Angle, side angle? Yes? Does this make sense? It's pretty straightforward. Can you do something like this for your homework or your test? Okay, good. Now, what do you guys know then about opposite angles over parallelogram? Raise your hand if you think you know. Yes, their congruent is correct. So that's our next theorem. See, opposite angles of a parallelograms are congruent. So let's look at this picture. Which angles are we talking about? If I had this parallelogram EFGH, which angles are we talking about? One person knows? So it says opposite. Oh, I guess you're writing. Okay, I'll wait. Go ahead and write this down and think about which angles we're talking about in terms of this parallelogram. Okay. Who can tell me then how we could? First of all, which angles are we talking about? Okay, somebody that have. How about somebody at random? How about Jonathan? Which angles are you talking about when they say opposite angles of a parallelograms are congruent? Good. HEF and HGF. Good. Are those only pair? And H and F, right? You could just say H and F, yeah, right? Good. So H and F are congruent, and if I didn't have this auxiliary line over here, E and G. Is that what they're saying? Right. Now, you're right. How would you go about proving then this theorem? Okay, there are many ways of course, doing this, but what's one way? Yvette, what do you think? How can you show that the opposite angles of a parallelograms are congruent?
Prove that the triangles.
Yeah, prove that the two triangles are congruent, just like before, right? One above and one below, right? Of course, then H is congruent to F, because we already said it, by angle, side angle, right? Those angles are congruent. Okay, how are we going to say then angle, the whole angle right here, E, and then the whole angle G are congruent? How are we going to say that? Well, if we drew this auxiliary line, those are not CP. You can't use congruent triangle, corresponding parts of congruent triangles at this point.
No, but if you prove that they're
right? So let's say that we have the triangle on the top and the bottom are congruent. We could say H is congruent to F. That's easy. How are we going to say then angle HEF and FGH congruent? Okay, think about this. Eamon?
The HG and the F are parallel, and HE and GF are parallel. So then you can say that angle 2 is congruent to angle 1.
Yeah, okay, good. So angle, we know that angle 1 and 2 are congruent. We said that before because those are the alternate interior angles, right? If two parallel lines are cut by transversal. And okay, so angle 1 and 2 are congruent, 3 and 4 are congruent. Does that help us?
Yeah.
How is that going to, what can you do? You could go through that way. What can we say next? Kev?
Oh, you could do angle 2 plus angle 3 equals angle 4 plus angle 1.
Yeah, by?
angle.
No. Angle 2 plus angle 1 is congruent to angle 3 plus angle 4 is because of the? No. Yes. No. No, it's not. If angle 2 is congruent to angle 1 and 3 is congruent to angle 4, we know that angle 2 plus 1 is equal to angle 3 plus 4 because of? No. Raise your hand if you think you know. Yeah, you can't write common sense as your reason. Then you will not get full credit for that proof. Anybody know? Okay, you guys remember this? If A is equal to B and C is equal to D, A plus C is equal to B plus D. You guys remember that? Yes, Josh. One person had the hand up. It's a special sort of substitution. It is. Shh, raise your hand. You guys remember this? If A is equal to B and what? C is equal to D, then A plus C is equal to what? B plus D. What property told you that this is true? This is like from, I think, first chapter or something. Raise your hand. Raise your hand if you remember. Justin? Addition property of equality. Right? Isn't it because of addition property of equality? You guys remember? Remember that? Like we learned that like very beginning. Right? If A is equal to B and what? C is equal to D, then A plus C is equal to B plus D. You guys remember that? Addition property of equality? So you could say that, and then of course you could use angle addition postulate and do all that, right? And then add 2 plus 3 is the same thing as H, E, F, and then 4 plus 1 is F, G, H, right?
Wait, how are you going to prove that?
Angle addition postulate. You add those to the angles.
Angle addition postulate?
Yeah, you add 2 plus 3, isn't this whole thing is H, E, F? Isn't, right? So you could say then, use substitution, you could say they're congruent, right? Yeah.
You can't use substitution.
Can you just change it?
Yes, you can.
Oh,
Why
if
not?
you put the M, right?
Yeah, you could use a measurement of these. Now, but there's another easier way. You could do all that, or what can you do? Anybody see another method of showing this whole angle E is congruent to angle G? Tony?
Why don't you draw another auxiliary?
Yeah, you could draw another auxiliary line HF, right, and show that the triangles on the left and then the one on the right are congruent by angle side angle, right? Then what do you know about angle E and G? They're congruent because those are the corresponding parts of the congruent triangle. So you don't have to use this auxiliary line, EG. You could use HF and do the same thing, right? So that's another way. So there are many ways of doing that. Okay. Any question on this? Okay. Let's then go to the last term of the day. What can you tell me about? Let's say I drew another diagonal. Some of you already read it. Okay. But anybody want to guess what the diagonals of the parallelogram would do if I were to draw another diagonal EF? What do you think this will do? How about as to you? What do you think? They do. They bisect each other. This is our last theorem of this section. So yeah, it turns out that the diagonals of a parallelogram, of course we have two of them, bisect each other. In other words, QM is congruent to what? MS, and is that Tony? And TM is also congruent to MR. Does that make sense? So they bisect each other. What does that mean when they bisect each other?
I know.
Raise your hand. Yes, Andrew?
They cut them in half.
Which ones?
The
They say bisect each other. Which segments?
diagonals.
Yeah, both of them.
Or,
Right? So in other words, M is what? The midpoint of
both
both of these segments. Yeah, TR and QS. Does that make sense? So I want you to now think as a group. How would you go about proving that TM is congruent to MR and QM is congruent to MS? Go ahead. Have you think. How would you go about proving this? How can you prove that they bisect each other? All right. Who thinks, now that you have some time to think about this, who thinks they know how to go about proving this theorem? By the way, do you think there's a reason why they named these angles 1, 3, and 4, 2 there? Yeah, I think so. Okay, so let's see. 2 people see it? That's it? After all this?
I think I know.
Oh, how about Dylan? What do you think? What'd you guys come up with? Do you want a hint then, Dylan? Okay, so Dylan, if I want to show that diagonals bisect each other, you have to show that the 2 triangles are congruent. Which 2 triangles do you think we need to show that are congruent? Shh. TMS and RMQ, that's it. If I could show that TMS is congruent to RMQ, or the ones on the top and the bottom, or the ones on the left and right. It doesn't matter, right? But you're right, it's good, it's better to show that the ones on the top and the bottom are congruent. Why? In this case, because they have name for these angles, right? Does that make sense? If I chose these two so on the side, I would have to use 3 letters to, right, refer to those angles. Why not use the ones that they give us the angles for? So is there a way to show, Dylan, that those 2 triangles, one on the top and the bottom, are congruent? TMS and RMQ. And you said it correctly. That's how you, those are the corresponding parts. Dylan, any idea? Okay, let me give you a hint, Dylan. What can you tell me about angle 1 and 2? They're congruent. Why? Because those are the alternate interior angles, right? Because we have 2 parallel lines cut by a transversal, right? Don't we know that we have a parallelogram, class? So we know that TS is parallel to QR and TR is your transversal. Can we do the same for QS? So angle 3 and 4 are congruent because if 2 parallel lines are cut by a transversal, then the alternate interior angle is congruent. Okay, good. Dylan, now, lastly, we have, okay, so we have 2 parts. We got 2 angles congruent. That's not enough. We need the 3rd part. What is the 3rd part that we need here? Dylan, what do you think? Yeah, wouldn't it be great if I could show the side congruent? Which sides? QRN, ST. Is there a way to show that QRN is congruent to ST? Exactly. Remember, we just learned that theorem. What do you know about the opposite side of a parallelogram? They are congruent. So we could use the previous theorem, right? So therefore, these 2 triangles, TMS are congruent to, TMS is congruent to RMQ because of angle side angle, correct. Does that make sense? So since they're congruent by angle side angle, guys, then we know that TM is congruent to RM and what? QM is congruent to SM. And then we're done, right? Because then that shows that TR and QS bisect each other. Isn't that right? Does that make sense?
Wait, so which triangles did we prove then? So it was T.
Okay, so I guess it didn't make sense. Okay, raise your hand if you have a question.
Me.
Yes, sir, Andrew.
How are the 2 segments of different triangles?
TS and QR? Is that what you mean? No. TM and MR?
Yeah.
Okay, who could explain that? First of all, Andrew, do you understand how we show that the 2 triangles on the top and the bottom are congruent?
Which top and bottom?
TMS and RMQ. Yeah, angle side angle. So then how is TM congruent to MR? Who could explain that part? Because Andrew's having trouble. How about Young? What do you think? Yeah, corresponding parts of congruent triangle. Isn't TM the corresponding parts to RM?
Oh.
Right? Look, which angle 1 is congruent to which angle, Andrew?
What?
Is angle 1 congruent to angle 4 or angle 2? That's why TM is corresponding sides to MR. And SM is corresponding parts of QM. Correct? Because angle 3 is congruent to angle?
What?
Angle 3 is congruent to angle what? 4. Those are the corresponding, right, vertices.
So we have to say that RM is congruent to TM.
Yeah. Okay, any question? RM is congruent to TM and QM is congruent to SM. Does that make sense? Let's... We don't?
No, never mind.
Oh, okay. So Jason, why don't you read this for us and see if it makes sense? This is the summary of what we just did. Go ahead. I'm sorry. Yeah, I keep forgetting. Here you go. Go ahead.
And for proof, you can prove that QM is congruent to MS and RM is congruent to MT by showing that they are corresponding parts of congruent triangles. Since QR is congruent to TS by theorem 5.1, you can show that triangle QMR is congruent to triangle SMP by angle side.
Very good. Any question? And Andrew, do you see why they say QMR, and since they start with Q, they start with S. And M is the right corresponding vertex. And then what? RN, which one? RN? T are the corresponding. Okay, so please be careful. That's important. Isn't that right? Because if you mess that up, then can you get this right on the test or on the proof? Does this make sense? Okay, so let's summarize these. First, we said what? Opposite sides of parallelograms are congruent. Okay. Secondly, what do we say about the opposite angles? Okay. What about then diagonals? They bisect each other. Okay. And from the definition, what do we know about parallelogram? Opposite side of parallelograms are parallel. Is that okay?
Yes.
So those are the properties of parallelograms. Any question?
No.
Does that make sense? And knowing those, right? You could do your homework for tonight. Is that okay? Okay, any questions?
No.
Okay, good.